Hi everyone, my name is Constant. I'm a recent PhD graduate from the University of Waterloo and the University of Lille. Today, I would like to present our work understanding dynamic peephole pointing using coupled and decoupled target acquisition on single and multiple surfaces. This work was done with my supervisors Géry Casiez, Sylvain Malacria, and Daniel Vogel. Nowadays, we have advanced tools and systems to enhance our physical environment. For instance, in our previous work, we developed an augmented lamp to augment and extend our desktop computing environment. For example, we can drag and drop the window using the lamp. When manipulating this lamp, you'll notice that only the information within the viewport is being displayed, while the other information is hidden inside the space. Some other use cases require moving the viewport over the physical objects to view content on them, such as the keyboard here. This two-step process of bringing an object of interest first into a peephole and then performing interaction on the target is called peephole interactions. And the way when users manipulate the viewport itself rather than the entire workspace to navigate space and review information is called dynamic peephole interaction. When designing those tools and systems to augment our capabilities in different contexts, a design consideration is whether this peephole manipulation and task interaction should be integrated into single devices, which we call coupled, or separated across different input methods, which we call decoupled. This design consideration is very important for dynamic peephole, where physical manipulation controls the viewport. For instance, with coupled control, we directly manipulate the peephole to find digital information on physical surfaces and then select it by pointing or crossing. This streamlines the process but changes the interaction sleepability. On the other hand, the decoupled approaches using other inputs such as touch allows specialized interactions at a cost of coordination complexity. With such rich interactions designed based on these two control mechanisms, we need a better understanding of their impacts. Another design consideration is the increasing dimensions of the virtual search space of our environment. Previous studies have investigated coupled and decoupled controls in 1D pointing tasks in a desktop setting or in a VR environment. However, the direction of a target is known and the search phase is limited to moving towards the target either left or right. Dynamic peephole pointing usually involves multi-directional movement on a single surface and can extend across multiple surfaces, introducing very different physical manipulation characteristics. In a multiple surface environment, the introduction of the visual guidance also eased the search phase, as it did not require participants to memorize the spatial locations of the targets. Searching the target is more difficult when the direction and distance are unknown. Our research question here is to examine whether target acquisition in a dynamic peephole should be coupled or decoupled when the search direction and distance are unknown on a single and multiple surfaces. In our work, our task was a retrospective pointing task where only one target can be viewed by the peephole, and participants were asked to search for a target within an area and acquire it. During the search for a target, participants do not know the direction and distance to a target, and they might accidentally view it but not be aware of it. So they might miss this target. This is different from 1D dynamic peephole target acquisition in the previous study, where the direction in the search phase is already known and participants move the peephole either left or right to find targets. When they find the targets, they are provided with the coupled and decoupled methods to acquire these targets. We use the flashlight or lamp metaphor to create a peephole display on virtual surfaces due to its popularity in many dynamic peephole systems as shown before. The coupled control uses a recasting technique where the peephole center is used for acquisition. While with decoupled control, we use direct touch to acquire the targets when we find these targets. To acquire accurate results of direct touch, we implemented a tracking and detection module using tracking cameras and a vibration sensor. We perform a calibration step to get the fingertip position from the tracking wing and use the vibration sensor only for detecting touch events. We combine these two modules to detect touch. In our pilot study, we achieve very high accuracy and low offset. Therefore, the whole task can be considered into two phases. Participants first search for targets without knowing the exact direction and distance, and acquire them using coupled and decoupled methods. We reconstructed the desktop space in a virtual environment using OptiTrack and VR headset in a single service study to avoid potential confounding factors with the real setup, and we recruited 16 participants in this study. Based on the results in the literature, we made the following hypothesis. Compared to the coupled condition, coupled condition first leads to faster total time. Second, coupled condition has lower accuracy. And last, coupled condition reduce the physical loads and efforts. Our results show that the coupled condition showed significantly faster acquisition time than the decoupled, but not in search time, total time, or error rate. We look at our results deeper by analyzing the Peephole velocity and target review percentage. We observed that with the same searching technique, coupled showed trends of higher Peephole velocity compared to decoupled. Given this observation, we computed the row peak velocity for each child and performed a low-value analysis as previous steps and found out the peak velocity of coupled was significantly faster than decoupled. Meanwhile, coupled condition also revealed targets later than the decoupled. These two vertical lines here mark the separation between the search phase and acquisition phases, and you can see that the line of the coupled appears later than the decoupled. For the task loads, the coupled control only requires significant temporal demand. It is more preferred for its convenience, reduced physical load with hand, and decoupled control is preferred for its accuracy, especially at small targets. On a single surface, we found out the coupled control was only significantly faster at acquisition phase. While there was no significant differences on the search phase, we observed an interesting pattern. Peephole moved significantly faster but viewed targets later with coupled. To study our research question further, we reconstructed a multiple surface environment as follows. Our space consisted of three surfaces. The horizontal surface for the table, the vertical surface in the front, and the vertical surface at the side. We reconstructed the desktop space in a virtual environment again using Vicon and VR headset to avoid the potential confounding factors, and recruited 16 participants in this study. Our results show that coupled and decoupled again had non-significant differences in accuracy, but coupled is significantly faster in total time than decoupled at side front. The coupled condition is also significantly slower at horizontal side than the other two surface pairs. Coupled is significantly faster in acquisition than decoupled at two surface pairs, except at horizontal side. Decoupled is slower at horizontal front than at horizontal side. We again look at the Peephole velocity and target view percentage and found a similar pattern. Coupled control moved the Peephole significantly faster, but revealed targets later than the decoupled. In a multiple surface environment, we found out that coupled condition was faster in total time, but was only supported in a very specific context. At horizontal side, coupled condition was significantly slower in the search phase, and also at horizontal side, coupled and decoupled conditions had no significant difference in the acquisition phase. This could be caused by the differences in body movements at horizontal side condition. We again find a similar pattern as the previous study. Peephole moved significantly faster, but revealed targets later with coupled. Given our results, we cannot provide a one-size-fits-all answer. In both studies, while coupled and decoupled show significantly different acquisition times, the total time was not significantly different on a single surface or only significantly in a specific surface pair. Search time, which showed no significant differences between these two methods, seems to contribute more to the total time when the direction of the target to search and select was unknown on a single surface or across multiple surfaces. But one thing we learned in the end is that with the same technique for moving peephole and searching targets, couple condition motivates faster peephole movement but reveal targets later, while decouple leads to slower peephole movement but reveal targets earlier. This may be attributed by the interaction goal of the peephole in the acquisition phase or its intended use in the subsequent interaction. Given the different performance characteristics of couple and decoupled, a system should consider which background or context these two conditions fit in. For instance, we could use couple for tasks requiring rapid acquisition with large interaction area, such as picking up a window or when a target is simply out of reach. For decoupled, we could use it when targets are easily reachable. When designing these interactions based on these two conditions, we should consider their impact on the search and acquisition phases and how they optimize these two different phases. In our experiment, we do not use visual cues, but we should consider visual cues when the systems or the surfaces become very complex, since these visual cues can help to reduce the target search time and improve the overall performance. To conclude, our work showed couple and decoupled control mechanisms lead to different interaction behaviors of peephole on single and multiple surfaces. Thank you.